Thank you. Yes, my name is Carlos Corrada-Bravo. I'm from the University of Puerto Rico, and I'm with also with a project that we call RBMON, which is co-directed with Dr. Mitchell Aide from the Department of Biology. And we basically, since we're a small island, we set up big goals. So our goal is to have an automated remote biodiversity monitoring network. So what do we thought we mean, and what do we mean? Actually, we want technology, all the available technology that it is, consumer electronics, etc. I know that from the session this morning, the sensors that have been built are going to be amazing, but we are working with consumer electronics more or less. And of course, biodiversity, birds, amphibian, we are going towards fish, marine mammals, and bats. We are building hydrophones, etc. But the main point is, I think it's long-term. We want to have long-term data. And this is something that we're trying to set up. So how do we do long-term data, right? Well, we have lots of biology, 24 hours a day, every day of the year. It generates observer bias. There's no permanent record, etc. So we want to do that with electronics, right? Right now, there's automated way to get biotic variables. We get satellite images for land use and vegetation. But how about fauna? So we're going to do sound to do the monitoring or the for the fauna. So the first thing is our goal from the beginning was to build tools that will help many ecologists that are working with this kind of monitoring. We are not looking towards one specific species of frog or of bird. We are trying to build up a system. So we have to help on the acquisition, storage, processing, analysis, and of course presentation as analysis and presentation as Judy was talking about. So this is what we want to do. We have the microphone, the biodiversity, send information through wireless, whatever communications we have. We will show you the antennas that we're using. Send it to a machine in the internet, servers, databases, etc. And have some of presentation in terms of spectrograms, and then some decisions as automated as possible, right? In terms of the presence of sounds in the recordings. So the acquisition part we are using, as I say, consumer electronics is it's a stage where I can go and pick up an iPod Touch, or I can go and do a computer on board, a board, right? An embedded computing board that I can do some stuff, do USB, plug an SD card. So these are the things that we're using. I'm sorry. And we build permanent stations. That this is one of the permanent stations we have. There's the antenna that it's connecting wireless, sending the data, small solar panel, and of course some abiotic information we get from sensors, and also we have I don't see I will show you the back that we have the recorder. And also we have some portable stations. We set up some camera traps, and we are working now with hydrophones. Hydrophones has not been tested yet. I mean, we are testing it, we are not deploying it yet. So this is what we use permanent station. As I said, these are things that we bought. There's basically here, the only thing we do is software to exchange information. And we are using a net-top computer. Camera trap we are setting. We build some electronics here, but the rest it's fairly simple stuff. And the antenna, which we have tested in Hawaii with a 40-kilometer distance. So we set up the recorder, and we found a high school that have internet 40 kilometers away, and they were happy to have our antenna, and we set up and send it through the internet to our web page, to our server, and to a web page. And this, we have also Sabana Seca, El Verde, Costa Rica. And this is how it looks like. And we set up camera traps. We do some controllers to have the camera take a picture and send it through to the computer and to the internet every time it takes a picture, instead of having to go there and pick it up. So we have real-time data in these permanent stations. Okay? The audio, it comes around 5 minutes delayed until it takes all the processing that we do and put it on the web. So this is a picture that was taken in Arizona. One of the stations is there. And then we have a portable station, which is based on the iPod Touch. And the iPod Touch is basically a controller and the recorder. So you can program it to have it schedule, record 1 minute every 5 minutes during the morning, and the same during the night, but only once an hour during the day if you're looking for frogs or birds or something. And this is something that was built by one of our students, undergraduate students in electronics, which is basically a preamp and power distribution for the microphone and the iPod Touch. I have one over there I can show you. I was planning to put it on this room that I cannot find, so Dale, you have to tell me what it is. Okay. And then we have the storage thing. And I just want to mention that I think it's a big problem, the storage part. We in a small, well, it's not a small university, but our department is fairly small. We don't have a data center to have. We are generating basically 3 terabytes of data every year, and we only have 9 stations, and we want to go to 1,000. So I don't think that we are hundreds of years storage. I mean, it's exponential, the storage that if you want to keep it for 100 years, what do you do? So we have to develop mechanisms to ensure funding to move this data to the new media that will come along. Our current solution is cloud computing. We have access, rapid access. We don't have to worry about data security. We don't have to hire system administrators to be sure that nobody's getting in. And for now, it's cost efficient until we start generating 10 years of data, and we have to pay for just being sitting there without knowing if it will be used, hoping that it will be used, but we don't know. Okay, so then the processing analysis. This is the main part of my participation in the project is the software, and we have built what we call a visualizer. This is one of the first part, which basically gives you the spectrogram, information about the recording, where it was taken, etc., and give you, of course, the places where there's some sounds. Okay, so and we also did some automatically. We generate these green squares, which we are calling them regions of interests. Where we have software that goes, an application that goes over the recordings and select and basically makes squares, boxes, around the areas of power. And this has been working fairly well. And we had, during the summer of 2007, we went and have students, graduate students, go and do what we call the ROI association. So they associate this is a co-key, it goes co-key, and this is the 2 notes, and and this is one species, so you have to make the association between the 2 notes, right? So this was done by hand, and the results were fairly good. We published that recently in Ecological Informatics using basic machine learning algorithms. As you see, we got with 4 variables, we got 93.8% for 9 species of frogs and 3 of birds, and with 11, we got a little bit better. Worst on the false. This is false positive and this is false negative. So we know that if we do it by hand, the machine can identify it. But we don't want a student to do all the association and then have 10% do a tenfold and decide if it's good or not. We want to do everything automatic. So this is. Sorry, let me show you what we are working now. It's I'm going to show you I myself creating a model based on hidden Markov model to identify one of the species of frogs. Okay, so this is our web page. This is available to basically anybody. Okay. So this is the browser that we have for the recordings. This is in Sabana Seca, a place that in the north part of Puerto Rico. And I'm looking for a random recording, very random, that I know that there is the species there. So I want to mark one of these species. I go there and play the recording. This is. I think that's audio, right? Yeah. So this is the recording, and this is and I'm looking for these guys over here. This is called a Brittoni. No, it's not coming. So let's get it up. Yeah, but because I took the. Oop, I'm sorry. Just to play the sound. It's okay. Did you hear that? No. Yes. Okay. So I'm looking. This is the. They are 1, 2, 4 at least species, and this is the guys that we're looking for. This is a Brittoni. You go the trrr, trrr. So this I'm going to build a model based on one marking of these species. Okay. So I will do. Yeah, it's okay. That's it. Thank you. So these green boxes were done automatically from our software, and I will do one association. Okay. As you see, there have many ticks, 4, 5, 6, but I'm going to use 2 to build the association. And okay, so with these 2 marks, I set up this. I tell the system what the species is. You can have a list of species already there. You can add new species or edit the ones that you already have. I select Brittoni, and then the sun type. We have many species that have different sun types, so we have to specify which is which, and it's the user is allowed to edit that also. And then I will have to say what syllable type this of the song. Of course, this frog has only one type of note, tick 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 tick. The coquille has 2, and the birds will have many more, 5 or 6. So then I do the association, and then that's it. I'm going to build the model, the hidden Markov model, to do the identification. So I go there and do the training, create the model, and it will come, ask me how many tons does this model have. This is a website that will be available for everybody, right? I mean, if you ask for permission, we will give it to almost everybody, right? So this is the model that we have. It's a finite state machine with one sound and a silence. So it's tick, tick, okay? So we're going to be very strict with the probabilities. We want to say from this first sound, it's going to go to the silence with probability 1, and from the silence, it will go to the sound with probability 1. Okay, so one tone and 2 boxes. Okay, so I'm setting up. This is the initial transition matrix for the hidden Markov model. Okay, and then I will submit as tested. And then with that one, I will do the training. Okay, so I will go Tritoni. This is the model I just created. It will search for how many, I will choose the place that I'm going to do the testing. Search how many I have already classified, and as you see, it's only one. And with that one, we're going to do the training. The idea with this is that to have as many people as possible do this kind of training, and then compare how good are the different ones, and use the common information to make decisions over the which is the best algorithm. So you see, we have many people working there, mainly students, undergraduate. And then there's option of filtering. How much diversity do you want to take? Variability, okay? And then I'm going to do this, trying to do this fast. So I'm going to select time during the night, because I know the species are mostly during the night. I'm going to find, to better train the model. So I start with one, define the threshold, how good it's an association. And then I start the detection algorithm over 500 recordings or 30 marks, the first thing that happens. So this will take, probably 10 more hours, seconds. And I will show you. So this is the result of the software. And as you see, you cannot see much, but it's basically all are good, right? The tick, 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 the trick, trick. We can go in and zoom and have the markings. These are the ones that are detected. We can see the recording that mark was made of. Let me show you also that there's information. Here will come. There's information on the frequency range, the duration. So I know it's something fast. So I know this is good. I know the range. So I can go ahead and click whatever I think is good as accepted. Okay? So I do this. I did this for 7 more. Okay? I went and did the selection, 7 more, and then train again. And these are the results that we got. This is mine. The blue one is the one that I did with 8. And this is the time of the day. And this is the percentage of recordings where this particular species appear. Okay? And we got 2 graduate students. The green and the purple is graduate students. And the blue, it's an undergraduate student. And this is they work on this basically, 3-4 days. There's my training set, it's 8. The red one, it's 89. The green one is 44 and 47. And as you can see, the data it's somehow good. we have we know that most of the calling is at night, right? We know that there's not many activity during the day. So we know that this guy it's doing a lot of false positive, right? But these 3 are fairly good. And we have to decide if this is the best one, the green one, or if the blue and the red are the best, right? So we can go inside the data to see that. But the interesting thing is that we didn't know that, and all 4 models agree that there's a peak during the 5 a.m., 6 a.m. We didn't know that. Everybody thinks that it's only, not everybody, but we thought that it was only during the night. So there's already information. This is run in 35,000 recordings. So a lot of data there. And then we have the month, and basically most people will say that this is the measure also of the rain, right? We'll see. This is something that we have to see. And I wanted to show you something that this is a species that is very rare for this site. It's a pig frog. And I did this myself, and I had to find 48 callings to be able to say that it was working, because it's very low in the frequency, and it gets confused with airplanes and rain. So we also we were surprised by this high in the calling during the 4, 5, 6 a.m. Okay? And during the whole year, one thing that surprised us was this peak here during January. So this is data that we are generating. We got 110,000 recordings already. This site has almost 40. And this is run over all those recordings. As you can see, it's only 3.5% of the recordings. So it's very rare that this species is there. So in order to go there and find specific recordings where this pig frog is very difficult if you don't know these kinds of tools. So this is what we want to keep generating. So future work, a lot in machine learning, web application for analysis. We sent a proposal that it's competing with Judy's, I found out now. Model for many species as possible. We think of on-site identification, uses the iPod Touch to do the analysis. I mean, once we have the training, doing the analysis, it's fairly easy. And then going to ultrasound. So that's it. Thanks to NSF and DoD Legacy, and visit us on RBMonNet. And there's some thoughts that I had, especially the last one, that something that Judy was mentioning, that immersion between ecologists and computer scientists is the best way to create a common language. Sorry for the